Have you ever wondered what lives in your backyard, or what made that strange noise you heard last night, or maybe even I wonder what lives in this hole out back? Well, wildlife biologists like me ask ourselves a lot of the same questions, and one of our best tools for answering these questions are camera traps. In this video, we want to introduce you to camera traps. What are they? How they work? What kinds of questions you might ask and answer with them? And what do you do with all those pictures? Hi, I'm Scott. I'm a wildlife biologist here at Black Rock Forest. Most of the time, I study carnivores, which is really exciting, but it can be really challenging too. Carnivores are usually rare in our landscapes. They're often only active at night, and I'm pretty sure they generally don't like to be seen. But luckily, we have a lot of tools at our disposal. One of my favorites are camera traps, like this one. I like to think of camera traps as my eyes and ears in the forest. They're efficient to use and they come with really cool results, pictures. So, in the next couple minutes in this video, let's take a look inside a camera trap. There are many types of camera traps used for different purposes with a variety of features. In general, camera traps are designed to withstand harsh field conditions for long periods of time. All camera traps have at least three basic features. They have a flash, like this here, a lens, like in most digital cameras, and a sensor. If we open this camera trap up and have a look inside, you'll see that this one is powered by AA batteries on your right. It saves all of its pictures to an external memory card like this one, and here you'll see a variety of buttons that allows you to program your camera to wherever you think is best to answer your questions. If we go back to the outside, we can have a look at the flash, which is up here in the top, and wildlife biologists like me prefer to use infrared flash because most animals cannot see infrared, and that way we do not disturb the behavior of the animal that we're trying to study. Beneath that is the lens, which functions just like any digital camera or even the camera on your cell phone. And here on the bottom is a sensor. And this is really the critical part of the camera because this is what tells the camera to take a picture. This camera, like most camera traps, uses a passive infrared sensor. What a passive infrared sensor is doing is it monitors the background of what it can see. So it's constantly looking at the environment, monitoring its temperature. So when a large animal or even a small warm-bodied animal walks into that field of view, it tells the sensor that something has changed and that triggers the camera to take a picture. Hopefully now you have a better understanding of what a camera trap is and how it works. So now, let's go decide where to put a camera trap. Now we're in the forest and we have to decide where exactly to place our camera trap. But before we got out here, we spent a lot of time looking at maps, thinking about our research questions and our study species. For example, one of the many projects we do here at Black Rock Forest is to investigate bobcat ecology. So we decided, based on what we know about bobcats, that this general area here is probably a good place to try to find them. But the real challenge is, where exactly do we place our camera trap to be certain that if there's a bobcat here, our camera trap will actually get a picture of it? So this is actually the fun part. We get to pretend for a minute that we're a bobcat. So one thing we want to do is we want to look around the landscape and think about what would a bobcat do if it were out here. For example, up here on my right, it's a pretty rocky, looks pretty unpleasant slope. I don't know if I were a bobcat if I would want to move through there. But over here, it starts to level out and you can almost start to see a little bit of a trail. The landscape is a little flatter. If I were a bobcat, maybe I'd want to move through there. And still over here on the left, things get a little rocky, a little bit steeper. I'm not so sure that if I were a bobcat, I'd want to go through there. So I'm thinking this flat area might be a good place to try to set our camera trap. So now that we're happy with our site, we found a good tree to strap our camera trap to. It's not too small, it's not too big. We're certain that our camera is facing in the right direction to observe what we need it to. We've also adjusted the angle so that the sensor of the camera is pointing parallel to the ground surface. The only thing we need to do is turn it on. So we turn it on, we wait to make sure that the time and date is correct, and after it's all said and done, we arm it. Close it back up. See you in a couple weeks. Okay, now the exciting part. After your camera trap has been deployed for a few weeks and you have collected the memory card that was inside it, it's time to look at all of those pictures. But first, let's take a look at a few examples and learn what data camera trap images can reveal. Here is an example camera trap image of a bobcat taken from inside of Black Rock Forest. You can probably already see quite a bit of data. On the top left, we have the date and time. Next to that, on some camera trap models, we might have a letter M for motion or a letter T for time lapse, indicating which method we use to trigger the camera trap to take a picture. The fraction to the right shows us that this is image 1 out of a sequence of 10. There is a range of frequencies for how often your camera trap will take pictures. For example, from once per day to rapidly in bursts of 10, like we did for this example. This camera trap model tells us the moon phase and the ambient air temperature, shown here in Celsius, two variables that may influence animal behavior. On the bottom left, we have the unique name we assigned to this camera trap. We can use this to cross-reference camera trap images with the location it was taken. And of course, we have the species. But don't forget, there might be more than one species in your photo, so look carefully. And lastly, although the location of where this photo was taken does not appear in the image, we have already recorded its coordinates into our field notebook using a GPS device or our smartphone when we deployed it in the field. Our camera trap images can reveal other forms of information as well. Here, for example, we have 3 black bears, a sow or adult female bear, and her 2 cubs. So now we have a count, 3, and we know that there is at least one reproductive female bear in our study area, which gives us some insight into the black bear population's health. Some individuals have unique features, like this coyote with a very short tail, that allows us to identify them as unique individuals. We nicknamed this coyote Bob due to his bobtail. Bob appeared at many of our camera traps, giving us a basic understanding of his territory. We might make other observations, like these 2 coyotes with sarcoptic mange. Mange is typically spread via social interactions, so it might be worth investigating whether there is something near this camera trap that is affecting the spread of this disease. And lastly, we can often see a behavioral display, like these 2 male white-tailed deer who are sparring with each other. Eventually, you will want a system for recording these data and observations in a clear and logical manner. In the end, you will likely have something like this table, with each row representing an image or sequence of images, with a series of columns representing the different attributes of each image or images. I strongly recommend that you think hard about your data management strategy before you set up your camera trap and deploy it. There are many good strategies, so we will not discuss them here, but I will say that a poor data management plan can create a lot of unnecessary challenges for your project. In the end, remember that camera traps can help us answer a lot of questions, but to answer them well requires a lot of planning and effort. Hopefully by now, you understand how camera traps work, you know how to use them, and you understand what sorts of data they can collect for us. So, what will you discover with your camera trap? And when the camera senses that when the sensor senses that's can't say when they're censored senses. We do this by looking at maps that are online or in our office or other fumble. There are many different kinds of camera traps used for a variety of different purposes. Oh my, why can't I do this? I didn't even say it.
All right. 3, 2, 1.
There are many different types of camera traps used for different purposes with a variety of features. In general, camera traps are rugged. They're made well, which is the same word,